For 13.1.8, we're looking at completing an Anova table, but not using StatCrunch. This is kind of where the data comes from, but normally we would use StatCrunch to do the calculations, but this just helps us see where the numbers come from. And so in an Anova table, remember what we're trying to see if there's a difference between multiple means, not just 2, but 3, 4, 5. And in this case, we come up with a new value called an F statistic. And to do that, that's what we use to determine if a p-value. But before that, you have your data, and then you end up with this table that StatCrunch helps us with, but you have some abbreviations from formulas here. And so after you have your data, you come up with what's called the sums of squares between the treatment and then the air. And so that's SST, SSE. Degrees of freedom for this situation, you end up with the formula K minus 1 N minus K. Your mean squares of the treatment, mean squares of the air is MSE, and your F statistic is your MST divided MSE. And so then you have a formula for this. So it looks a lot more complicated than what it is. And so in this case, what we do is first you need the total here. That would be what comes up next, the total. And so in this case, sorry about that. And so in this case here, this would be 23. This would be 6,505. The mean square with treatment is just going to be 497 divided by 2 equals something. This one here is going to be 6,000. You divide this divided by this, and that's how you get your mean square error, MSE divided by N minus K. So those are the values divided by 21, and then you get your answer. And then after you have those two answers there, you get this answer here. This turns out to be 248.5. This one turns out to be 286.095, and that's three decimal places, 2.5. That's exactly. And then your F statistic is your MST divided MSE, and so your F value is going to be the number here. This F value is going to be 248.5 divided by 286.095. And that's your S statistic, and that's how you would get those values and complete the table. And I get 0.869. And so that's what you do.